Okay, so distance, speed, and velocity. Okay, so what is the difference between distance and speed? Right, so if you look at it, distance is the distance traveled between 2 points A and B, regardless of the journey. So I could have done that. So that's the point A, and this is the point B. So the distance traveled is the length of that line. Displacement is basically distance, but in a straight line. So this time there's point A, point B. It is the distance in a straight line. So this one is distance, and the symbol being a lowercase d, and this one is displacement. And the symbol for displacement is S. Okay, because the D is used for distance, so we can't use that one again. One other thing on this is that if we have a journey that starts at point A and takes that route and ends up coming back to the original point, then in that case, we have the displacement is equal to 0, because the distance in a straight line from the start to the end point is 0, because the start and the end point are exactly the same. So therefore, it is 0. Yes, we are starting forces 2. So if you've got any questions, again, put them in the chat. I'll address them at the end of this. It's easier. Okay, so that's the first thing, the difference between distance and displacement. Distance is a scalar, displacement is a vector. Right, then we've got speed and velocity. Okay, speed is a scalar. Check focus. So speed is a scalar. Let's go with, that's a speed. And velocity. So velocity is just speed in a straight line. So this one is a scalar. And this one is therefore is a vector. So remember, vector is magnitude and direction. Right, you need to know the speeds, the average walking speeds for walking, running, and cycling. Okay, so you could write down the labels walking, running, and cycling. So this is in meters per second, or you could actually draw it like I'm going to attempt to. So this is somebody walking. There you go. And their speed is, the walking speed is 1.5 meters per second. Put a bit of color into it. So 1.5 meters per second. Right, now my version of running. I use my very, very best A-level art here. And a few go faster stripes. There you go. And the average running speed is taken as 3 meters per second. And then you could do cycling. Here we go. There's my bike. I'll do a bike. Right. It's a weird looking bike, but there you go. And there's my legs pedaling away. And the average cycling speed is 6. So you need to know those numbers. If you notice, they just double up each time. So that's the way of remembering them. So remember 1.5 for walking, and then it's just doubling each time. Okay. And we have an equation. Okay, let's see what we'll do for equation. We'll do dark blue for equations. Your equation is speed is displacement even, distance is velocity multiplied by time. So we've got displacement is equal to velocity multiplied by time. Okay, I'm not going to write down what the symbols are because I've written those already. And if you can't figure out the t is time, then you're going to struggle anyway. Okay, so just note the equation. So there's an equation, so you need to learn that. Make sure your equations stand out. So you might want to do something to make it stick out a bit from the rest of the page. Because those are the ones you absolutely must know. So that's the first lesson. That's all you need on displacement, speed, and velocity. Then we're going to do our distance time graphs. So a bit consistent with our colors, distance, time, oops. Okay, so this one's is really just the shape you need to know. So draw a graph. And the three different things we need to look at. So you have a graph of distance against time. So we could have, I'll do it in black pen so it stands out, three situations. So we'll label that situation 1, this one situation number 2, this one is 3. So we got 2 lines at a gradient and then one which is horizontal. So position 1, position 2, and position 3. What do they represent? Okay, and what we can do is, what color shall I use for this one? Oh, the choices. I like a bit of pink. Here we go. So number 1 is a high constant speed because it's a steeper gradient. I'll just write all that. High constant speed. Number 2, a lower gradient is a low or lower constant speed. Okay, so straight line with a gradient is constant speed in the distance time graph. The steeper the gradient, the higher the constant speed. And as you probably know, a horizontal line is stationary. So you'd need to be able to recognize if you're drawing a distance time graph, what the shape of the graph looks like. Okay, and now how to calculate the speed. The speed is the gradient. Speed is equal to the gradient of the graph. So the y value over the x value, distance divided by time, because on our equation that we just wrote down earlier, speed is distance multiplied, or sorry, distance is speed multiplied by time. Right, this next section is just for the higher tier only, because they need to find out the gradient of a graph that has got a curve on it. So on the distance time graph, so if you're not doing higher tier, this won't apply. So I'll just put down HT only. Okay, we have our distance time graph. And if I try and draw a curve, let's go curve that way, it's easier. And on this one, to get the speed at any particular point, let's say the point being this point here, okay, you draw a tangent to the curve at that point, preferably using a ruler, because it has to be drawn accurately. So you only touch at that point only. So draw your tangent in there. So that bit is the tangent. And from there, you take then 2 points on that line. Doesn't matter which 2 points. You would choose 2 points that line up nicely with the graph value. So that call that one x2, y2. And this point is x1, y1. And therefore, the gradient is equal to the difference in the y values, so y2 minus y1 over the difference in the x values. Okay, mostly you might just get it, so you would take it intersecting with one of the axes, so therefore the point becomes 0, makes it easier to calculate. You could do that, but it doesn't matter where you choose those points, so you choose them to make the numbers nice and even. So the gradient is the y value, or the change in the y value, over the change in the x value.